Okay, first question. So focus in because, again, some of these, not some, for sure, letter B is a question you will see. There is no doubt about that. So a statistics teacher has 40 students, 23 females, 17 males, so they're not equally distributed. However, it's 23 and 17, it's close. At the beginning of class Monday, the teacher planned to spend some time reviewing an assignment during that day. Unknown to the teacher, 19 females and 11 males completed the assignment. The teacher plans to randomly select to do the problem for the assignment. What is the probability that a randomly selected student has completed the assignment? So, of course, I'm thinking you guys have been in this by now quite a bit. I should have this on something I can do. I can't write on this. You're going to need two things to get an E. You need the answer, either 30 out of 40 or 0.75, and you got to have some kind of work to validate that answer. Something, rather it be a table, rather it be 19 plus 11 over 40, I'm sorry, it's over 40, so they gave you 40, so you could put that straight over 40, but you got to have something to validate that answer, okay? Take a look at the model solution. The model solution, they made a table. I saw several of you guys making a table. I'm not sure how necessary the table was. However, the table helps you get the answer. You can see from the table, the completed assignment is 30 out of the 40. Probability of being complete, I did see several of you have the probability statement. You should write it to be safe. However, it was not required to get an E this particular time. Part A is scored as follows. Essentially correct that the response calculates the correct probability and shows work. Example includes the fraction 30 out of 40 or a two-way table. And pretty much those are the only two things that you could have. Partially correct if you calculated the correct probability, but you don't have any work. It's not necessary to to include a two-way table. So you don't have to have the two-way table as long as you have some type of mathematics. Here's this student here. They made a two-way table. They put the probability of complete is equal to 30 out of 40, and then they put 0.75. That's great. That's an E. This student here said the probability of complete, 0.75. They got a P. They actually got the right answer. They just got it. You got work and the wrong answer, it's an I. You got to have the right answer at least. Good enough with that. Okay, the second one, proving independence. You've got to prove independence or lack of independence, one of the two. So prove it's independent or show that it's not independent. And guys, the only way to do that is with numbers. We can't say having an accident or because it's raining, you're more likely to have an accident. That doesn't show any independence or dependence, okay? That just states it, but you don't have any mathematical proof of it. You've got to have mathematical proof. And this particular one, they allowed several things to prove that it's independent. So soak this up because, like I said, this is one it's not that hard if you've done enough practice of it. So, no, they are not independent. Probability of being complete given that they are female. Probability it's complete given that they're female is 19 out of 23, or 0.826. That's not equal to the probability of being complete. So they did it a little bit different than the way we did it in class. We showed the probability of complete given that they're female is not equal to the probability of being complete given that they're male. And that's one way to show it. You don't have to show probability of complete given female and probability of complete male. You can just say the probability of complete, which is, I think, is probably the easiest. Let me show this and show it just to make sure you guys understand what I mean. Okay, here's what I mean by this, guys. Probability of A given B. Okay, so given that B's happen, what's the probability of A? That's what that says. If that's equal to the probability of A, which is just that last side, that last table, then we don't care if B happened or not. If B happened or not, then if A happens, they must be independent. They must be independent. In class, the one we showed you, we said the probability of A given B, if it's not equal or equal, whatever, to a probability of A given C, or something to that effect. B given, these have to be the same. Those have to be the same, okay? The way we did it on the two-way table, we said if this over this is the same as this over this. If those are the same, it's independent. If they're different, it has to be dependent, or let me rephrase that. I don't like to say dependent. They don't like to say dependent. They say not independent. Okay? Now, what they did on this top one, and I think this is the easiest way to show it. Probability of A given B, if that's the same as the probability of A, which is this over this. But I held it too long. Okay? So any ratios, if they're the same. And so let me, again, we'll go back to the rubric just to show you what they said, okay? Part B is scored as follows. Part B is scored as follows. Essentially correct that the response indicates a two-way value, must include these three things. Correct computations of the two values. So you got to have correct computations. You can't just say this is some value, whatever it is, and this is some value, whatever it is, and those not be right. If they're not right, then you don't get credit for A. So whichever one you decided to use, or whichever two you decided to use, because you had to have two. You got to have two. You got to have this fraction equals this fraction, or this fraction does not equal this fraction. And they didn't equal. So they had to be correct. An explicit statement of if those two are equal or not equal. An explicit statement in their example is not equal to, but I would just have a two equal sign with a slash through it. That's an explicit statement. An appropriate conclusion about the independence. No, they are not independent. You had to have those three things. And then down here at the bottom, partially correct if you only hit two of those three. Partially correct if it identifies two values who are inequality. It implies a lack of independence. Okay, note, other valid comparisons include the probability of being complete given they're male, probability of complete given that they're female. I said that backwards. Probability of female given complete, probability of female. Probability of female given complete, probability of female given not complete. Probability of female and complete is equal to the probability of female and complete. We didn't talk about that one. Students yesterday, after working on some of the homeworks, decided they liked this also. Here's another way to show independence, and it goes off of one of your rules. Right? We said if the probability of A multiplied by the probability of B, if that is equal to the probability of A and B, then they have to be independent. They have to be independent. Because if the probability of B given A is equal to the probability of B. So in other words, if you have a table here, if this is the intersection, that's A and B, that's A and B. If the probability of A multiplied by the probability of B is equal to the probability of A and B. That's probably easier than any of the others. That shows independence also. That's what we'll do in chapter 12. So we'll bring this back up in chapter 12. But if the probability of A, which is nothing more than, provided that's 1, right? Provided that's 1. If that's the probability of A and this is the probability of B, if you multiply those two together and you get that number, they have to be independent. They have to be independent. Beautiful. Okay. Now, this student here says, no, probability of complete equals 0.75, but probability of female is 0.575. Nothing. Nothing. They don't care the probability of complete does not equal the probability of female. That has nothing to do with it. Probability of female is equal to 23 out of 40, which is 0.575. Probability of female given complete. So that's female. This is female given complete. Is not the same as, and here's where they said not equals to, the events are not independent. Good enough there. Provided these two are right, which I think they are. Those have to be right. Everybody okay with that? Again, kind of see how I'm doing this when I'm grading these. All right, C. C was bad. C was bad, and it's mostly bad the way they asked the question. Okay? But sometimes they don't ask the greatest of questions. You guys had a test last time. We'll only choose the bicycle that none other is cost more or that has higher quality. Right? Something like that. And a lot of you guys got a little confused on which ones you would choose. In part C. Part C. Oh, let's go with the question. I'm sorry. Let's go with the question. A, B, C. So let's break this down. Suppose the teacher randomly selects 4 students. So we're going to select 4 students. So remember what we got, right? We got a classroom of 40. We're going to randomly select 4 of them. Might be a male, might be a female. There's a better chance it's a female than it's a male because there's more females. But who cares? We're going to choose 4 at random. They're going to do a problem on the whiteboard. Only 2 of those students had completed the assignments. We already know there's a 75% chance that they completed the assignment because that's what we did in A. Okay, there's a 75% chance they did. We only had 2 out of the 4. Describe how to use a table of random digits to estimate the probability that only 2 or fewer of the 4 randomly selected students completed the assignment. Now, I don't know if you were asked anything like this prior to this, but we kind of have to understand a little bit of the knowledge. So let's kind of look at this, right? Let me go back to a whiteboard so that I can write. Refresh. Sure. Reload. Is that going to give me back my marker still? No, it won't. Okay, so we know that 30 out of the 40 completed the assignment, and I've got to use a table of random digits. And so there's 2 ways to do this and get it correct. Allow the numbers 0, 1 through 30 to represent the students that completed the homework, and represent the numbers 31 through 40 as students who did not complete the homework. But then you got to mention ignoring repeats, and I got to ignore 0, 0, and 41 through 99. You got to ignore those values because those are not part of the 30 or the 75%. Now, another way to do this, guys, and some, just understand this. This has been showing up every once in a while. So I want to make sure that this is how you do this. You could say 0, 0, but then this would be through 29. And then we would go 30 through 39. And then I can ignore 40 through 40 through 99. Okay with that. Those are the 2 ways that you could do this. I don't think you can do 3 through 4. Like 1, 2, and 3, 4. Because I don't think that's the same chances of being, like there's more possibilities. Okay, and I don't think I can go 0 through 75 and then 76 through 99. I don't think I can do that. Okay, I think I got to do the 30 and the 40. Okay, and now you got to talk about all the different, well, you got to talk about ignoring the repeats, and then you got to do this, you got to go until you get 4 numbers to see how many out of those 4 did it, right? So I'm going to go through the first, however many 4 it takes, and see how many did their homework. And when I do that, I'm going to plot that number. And I'm going to go through the next 4 and see how many did it there, and I'm going to plot that until I get what? A whole bunch of dots. And when I get a whole bunch of dots, I'm going to compare 2 out of those dots and see how many show up. You guys are used to what? Seeing the dots and then seeing how likely 2 is to show up. This time they wanted to do it like 4 times, I think. I know. That was hard. That was hard to get. And when you see it like this, I don't think it's that hard, but trying to get this out of that question is hard. Okay? But I do think you need to know how to deviate numbers in order to simulate some event. Some event. And you already said at 75%. Most everybody got that part right, so we got to understand how to divvy that up. Okay? Now, let's go back to the rubric. I need to pull up one more. Sorry, let me pull up one more. Rubric. Go. There it is. Okay. Here is the perfect answer, the model answer. Sorry, I went too far. Here it is. Let 0 through 1 through 30 be the completed assignment. 31 through 40 didn't complete the assignment. Skip 0, 0, and 41 through 99. going from left to right on a random digit table, choose 4 different, guys, thanks. Choose 4 different 2-digit numbers from 0, 1 through 40. Kind of have to state that. Count the number of students among those 4 chosen who completed the assignment, i.e. how many numbers are between from 1 to 30. Repeat this process many times to estimate the probability that 2 or fewer students completed the assignment. Divide the number of trials where 2 or fewer completed, and we'll see how possible 2 is. Again, that would be brutal to try to get an E. Brutal to try to get an E. Here is essentially correct. Uses a valid assignment of numerical tables for the 40 students. Uses a valid assignment for numerical tables for the 40 students. Describes a process of selecting 4 different students using that table. And then records the number of students in the group of 4 that completed the assignment. So the rubric seems easy. Hitting the rubric is not. Again, you haven't seen a whole lot of questions like this, so I don't put this necessarily on you. Notes: a valid assignment of numerical values means that each label in the same length and each student who had completed the assignment has a 30 out of 40 probability, a 29 out of 39, or a 30 out of 39. Because if you do 3 out of 4, you don't have a next student. Like there's not 39 students next. There's still 40 students left. If the response doesn't make it clear that the sample is being selected without replacement, the response doesn't earn for the second component. To earn credit for the third component, the response must clearly describe what should be recorded at the end of each trial. It isn't necessary to include a statement about how to calculate the probability, so you don't have to include anything about the end of that. All right, now, this is the way that they wanted you to carry this out. 1, 2 would be somebody that completed the assignment. 9, 7, I have to skip. 5, 1, I have to skip. 3, 2 didn't do their homework. 5, 8, I have to skip. 1, 3 did. 0, 4 did. So that time 3 out of 4 did, which is 75%. That should be right. Next group: 8, 4 skip. 5, 1 skip. 4, 4 skip. 7, 2 skip. 3, 2 didn't do it. 18 did. 19 did. 40 did not. There's a time where 2 didn't do their homework out of random selection. 0, 0 skip. 3, 6 did not. 0, 0 skip. 2, 4 did. 2, 8 did. And 9, 6, 2, 3 did. Okay? So in trial number 1, 3 out of 4 completed it. In trial number 2, 2 out of 4 completed it. In trial number 3, 3 out of 4 completed it. Most of the time, what? 3 out of 4 will complete it because it's 75%. Most of the time, 75% will. There'll be sometimes there'll be some 2s. There'll be sometimes that all 4 did it. There'll be sometimes that none of them did it, but not very few of those. Again, I don't expect you to do that. There's a really good chance I won't ask that on the test because it's really hard to grade. Okay with what I'm saying on that, right? My test probably won't, but I think it's important that you, and you're going to see some homework questions or some review questions, which one of the following, and you saw some, I think, which one of the following will simulate this process? I think that's what you need to know, is which one would simulate it, not necessarily how would you do it. Fair enough with what I'm saying? What do y'all got? Questions? Y'all good? A, you really need to know how to do. B, you really know how to do. I don't think you need to know how to do C. However, if you were given C, you need to know that that's the only way to do it. Okay with that? All right, let's make sure we're all on the same page, guys. I don't want any confusion. Some of the last chapter, there was a little confusion. So that's on me. I get it. I'm sorry. Okay. So I'll remedy that. You have what? 5.1 out of achieve. You have 5.2 out of achieve, 5.3 out of achieve, and 5-point review out of achieve. I assigned that, I think, yesterday or day before. If you didn't notice, it's no big deal because it's not due until test day, which is Monday for you guys. Okay, so that's assigned now. It hadn't been, you hadn't noticed it was probably assigned, but it is. That's due Monday. So you got all these out of Achieve. I'm getting ready to give you a worksheet. If you want to call it a worksheet, it's a packet. I don't know. It's 9 pages. 34 questions. It's not too bad. 34 is pretty high, but that, guys, I got to get you guys to practice somehow. And the only way to get good at this stuff is to get comfortable and just get practice. 34 questions from now until Monday. If you do 5 a night, you're okay. And don't try to do it till Monday, though. You wait till Monday, you're going to be in trouble. Just a word of caution. You're going to be in trouble if you wait till Monday. Okay? So work on those some. You got 2 class periods. You got this class period and next class period. Okay? So I'm going to take that bad boy up to see how you did on it. Okay? All right. Now, I'm going to post in classroom, multiple choice practice like I have always previously. Okay? Multiple choice. On AP classroom. Now listen to me, please. Listen. I'm not assigning it for a grade. However, if you get it done, it might fix something that you didn't do previously. Fair enough with what I'm saying. Okay? Now, how much? These are not progress checks. I could not assign progress checks. If you guys remember, Unit 4 is chapters 5 and 6. And so a lot of the progress checks involved chapter 6, which you have no clue how to do. So I went through and found topic questions, and I think there's 4 topic questions. But you will actually see the topic. So if you know you're having a tough time with independence, there's a topic on independence. There's a topic on, what do you call it? Conditional. And then there's a topic on rules, and then there's a topic on simulation. And that's pretty much what the chapter was. So if you do those topic questions, I might can concede fixing some stuff previously. They're great questions. There also is videos. There's also, I opened up the videos for that chapter that you can see somebody else teaching them to you, which probably doesn't take near as long as what I do. Y'all okay? None of this is for a grade, per se. It can help you, but that goes without saying. I don't ever tell you that you can do something or you don't do something. And then hopefully by Friday, I'll find a couple more free responses for you guys to practice, because the feedback I got on that was positive, so I got to try to do that for you guys. Any questions about what we got going on for today/Friday? There's no questions on Monday because we know what that day is. Everybody okay? Happy, happy? Joy, joy? Yippee, yippee, yo?